Hello and welcome to Chapter 5, Section 3, Rate of Change and Slope. Rate of change is a ratio comparing the amount of change in a dependent variable to the amount of change in an independent variable. So, if we remember from last chapter, y is what happens when you change something. X is the variable that you changed. X is the independent variable. You have control over the x. You get to pick which x's that you use. Where y is the answer. This is what happened when you change something. So if we're going to have a ratio of dependent and independent variables, that just means we're going to put x and y in a fraction. So the rate of change is the change in y divided by the change in x. And change means subtraction. So if you have 2 points, you're going to take the 2 y's and subtract them. You're going to take the 2 x's and subtract them. And that gives you your rate of change. We also call our rate of change the slope. And this is the formula for slope. Now they start you off with a word problem and they give you a table of how much it costs to mail a 1-ounce letter in different years. And what it's asking for is the rate of change in each interval. So we're going to have to go from this one to this one, and from this one to this one, and from this one to this one. And remember, these are our x's and these are our y's. So we're going to take the change in y divided by the change in x. And when we do this, negative numbers are a pain in the neck. So let's do it big number minus small number. So you have, if you're going to do it this direction for this one, you're going to do it this direction for this one as well, which granted doesn't mean anything if it's 25 minus 25, but it does mean something here. You want to make sure you're doing the same x's and y's first. It doesn't really matter because if you end up doing the other ones, you're going to get a -4 over a -1, which still equals 4. But you want to make sure you don't go one direction one way and the other direction the other. That's going to give you a negative number, which gives you a negative slope, which means you're going to graph your line wrong, incorrectly. So please make sure you're aware of that. Each one we're going to do the subtraction for, and we're going to end up dividing, and using a calculator here is just fine. Now, what it's asking us for, during which time interval did the balance decrease at the greatest rate? Which one is the biggest number? That's all. Go ahead and do check it out number 1 on the bottom of 314. Pause the video here and come back when you're done. So check it out number 1 asks you for balance of a bank account on different days, and it gives you the chart, and you're going to make sure to do your subtraction in the same direction each time, and then this first one is the greatest rate. Then the next question so that one was how to look at a chart and find So that one was how to look at a chart and find rates. Now we're going to try and find rates from a graph, just looking at the graph. You're going to use the points at the beginning and the end of each line segment in order to find the rate of change. That's going to give you all of your x's and your y's. So now you have to make a chart so you can do this. And just so you know, if your answer is going to be a negative answer, your slope is going to go down in this direction. And if your answer is positive, it's going to go up in this direction. So on page 315, you have an example that discusses finding the rates of change from a graph. So for example 2 here, you have what I consider a very bad example because you can't tell exactly where each of these points are when they don't end up at exactly the spot on the grid lines. It's difficult to tell, though they do happen to give you all of the numbers that you need. They're doing the subtraction for you. So here, from this dot to this dot, you can see that it's a completely horizontal line. 0 cents have changed. The cost has not changed at all, though 2 years have passed. So it's going to be 0 cents per year. From this point to this point, you go up 4 and over 1. So the change in y is 4 and the change in x is 1, 4 over 1. So that's a slope of 4. From this point to this point, it goes up 8 and over 13. So the change in y is 8 and the change in x is 13. And when you do 8 divided by 13, you get 0.62. From here to here, you go up 5 and over 4, and 5 divided by 4 is 1.25 cents per year. Now, check it out. Number 2 asks you to graph the data from the first one, and these numbers are too difficult to graph. So what I've asked you to do instead is to go to page 318 and do number 2. Next, we're going to decide on the slope of a line. We're going to put all of these ideas together to see how it applies to a linear function. So we're going to talk about the rise in a line, which is the difference in y values, y from the first point minus y from the second point, and run, which is the difference in x values. And our slope is going to be rise over run, which is the change in y divided by the change in x, which is what we talked about at the beginning of this section. So if I were to ask you to find a slope giving you just 2 points, we're going to drop these numbers into this equation. And I'm going to label these y1 and the xy1 and these xy2 just because these numbers are bigger. And the subtraction works better. So 3 minus 1 is our y's, and 2 minus 1 is our x's, and we end up with a slope of 2. This works really well in everything except a perfectly horizontal and perfectly vertical lines. So those are our special cases, and I'd like to show those to you today. In this case, where we have a perfectly horizontal line, and I've pulled 2 points off of it, I end up with my y's being the same number. All the y's are the same here. So my y's end up being 0 when I subtract them over whatever this happens to be. So 0 over anything is 0. However, this line, this vertical line, when this happens, then the x's are going to cancel each other out, and we have a fraction with a 0 on the bottom, and this is undefined because this is not a linear function. So be careful when you've got horizontal and vertical lines that you remember the difference between 0 and undefined as your answers. Otherwise, we're just going to look at slope for your average run-of-the-mill linear equations. If it's got a positive slope, that means as you read it from left to right, like time is going by, that line is going to go up. A negative slope means that line falls as it travels to the right. If it's a horizontal line, it says it has no slope, or it has a slope of 0, because there is no change in rising or falling at all. It is a flat horizontal line. And then, of course, this one is an undefined slope. That's the vertical line. Slope can be measured in steepness. The bigger the absolute value of number, the closer it gets to vertical. So this linear equation has a slope of 4. It's positive. This linear equation has a slope of -9. So as it goes left to right, it's going to fall down. And notice that the steepness here of -9 is more than the steepness of +4. And a slope of -1/3, which is smaller than the absolute value of 1, that's going to be a very gradual decline, not steep at all. Granted, these are very general terms, but this is just here to kind of introduce you to these ideas. So if you could do the check it outs numbers 3, 4, and 5 starting on page 315. Pause the video here, come back when you're done. Check it out number 3. We have 2 points that they're giving us. We're going to do the changes in y divided by the changes in x, and we're going to end up with 2 over -5, which gives us -2/5. Number 4a ends up 0. It's on the denominator. That makes it undefined. And b gives us 0 on the top, which means we have a slope of 0. 5a is undefined because it's a vertical line. Line b has a positive slope because it is rising as it travels right to left. Your homework tonight is going to be numbers 18 through 28 all, starting on page 318. Okay, let me know if you have any questions, and I will see you tomorrow.